Okay, Tyler, why don't you go ahead and show me what you got here.
Can you see that?
F of x equals x squared minus 1, g of x equals x plus 2. Okay, yeah.
Yeah.
Okay, so what was g of x again?
F of x was x squared minus 1.
Minus 1, okay. And g of x was?
X plus 2.
X plus 2. Okay, so those are two functions. Remember what it means to be a function. You're going to input values, and then the rule tells you how you're going to calculate the output values. So, for example, can you tell me, oops, there you can see that better. So can you tell me what would f of 2 be?
You just double what f of x is?
No, f of 2. If f of x is x squared minus 1, the rule is telling you when I input an x, this is what that's the rule. That's telling me what I do with the input value. I'm going to square it and subtract 1. So f of 2 would be?
You just multiply it by 2?
You'd square it. So f of 2 would be wherever, remember this rule we talked about earlier in the year? When I evaluate a function, that's really all I'm doing here is I'm evaluating a function. When I evaluate a function, I'm just going to open a set of parentheses every place where I have an x in the function. And then I'm going to plug in whatever value I input for x. So I would just get 2 squared minus 1, which would be 3.
Okay.
Okay, does that make sense?
Yeah.
So when I input an actual value of x, then this tells me what I do to get the output. So f of 3 would be what?
This would cube 3.
It's square 3, you mean?
Square 3 and then just subtract 1.
Right. So I'm going to get 3 squared. So 9 minus 1 would be 8. Good. Okay, what would g of 5 be?
7.
7. Good. You got it. Okay. So that's just a quick reminder about what it means to be a function. Okay, when you do compositions of functions, you're going to do functions of functions. Okay. So for example, if I were to do f of g of x, okay, now what's that saying? That's saying I'm going to perform the rule of f on the function g of x. In other words, I'm inputting g of x into the function f. So we'll follow our same pattern as before. If f of x is x squared minus 1, well, I'm just going to open a set of parentheses and for the function f, and every place I have an x in the function, I'm going to now input g of x. Okay, so f of g of x would be g of x squared minus 1. See what I'm saying?
Okay.
And so what would that actually be then? Well, we know what g of x is. G of x
would be x plus 2 squared minus 1.
Exactly. Yeah. And so all I'd have to do then now is just simplify that. So I could square out x plus 2. And if I square out x plus 2, I'm just going to get x squared plus 4x plus 4. And the way I would get that, I don't know, did they talk about expansion patterns? Like, did they ever show you this? I can't remember in his videos if he shows this. A plus b squared is a squared plus 2ab plus b squared. Did he ever show you that?
No.
Okay, that's okay. It doesn't matter. Then all you'd have to do is just, when you do x plus 2 squared, you would just do x plus 2 times x plus 2. Well, this would be the same thing. Actually, yeah. Didn't you do have you done the binomial theorem stuff yet?
Yeah, he did it. It's kind of, he did it a little different.
Right.
But I get where you're going with.
You get where I'm going with that, right? Yeah. So then when we expand that out, we're just going to get x plus 2 squared is just going to give me x squared plus 4x minus 4, and then I'll subtract 1 from that. And I just use regular order of operations to simplify this, right? How do I know which one to do first? Well, this is the stuff we've been doing forever.
Yeah.
I would simplify, inside the parentheses, I would work first. Then I would deal with the exponent, so I'd have to square that out. There's no multiplication. And then I would just add and subtract like terms, and I could just combine those two like terms. And I'd end up with x squared plus 4x plus 3 would be my answer.
Okay.
You know what I'm saying? Okay, now, so that's one way of writing it would be.
And what about the G? When G
Okay, we'll do that next. Yeah, we'll do that next. So f of g of x, there's another notation for that you might see also. It's f and then a tiny little o, f of g of x. That means the same thing. So if the f comes first, I think this is maybe one thing you were going to ask about, I bet. If the f comes first, then it's the outside function. Whichever comes second is the inside function that's going into the outside function. Okay, so if we did something like this, what if we did g of f of x? Well, that's the same thing as saying g of f of x. And so we would just, there's really no preference for f or g. They're just different functions. Now we would just reverse what we did last time, right? So now we're going to use the same rule. We'd have g of something. Whatever we have g of, remember what our rule is. We're just going to open up a set of parentheses for whatever we're inputting into g. And what's our rule for g? Well, our rule for g is we're just going to add 2 to the input. So g of something would just be something plus 2.
So just be x squared minus 1.
Exactly. Yeah, it's going to be f of x plus 2, which is x squared minus 1 plus 2, which is just x squared plus 1, right?
Mm-hmm.
That's it.
And then we wouldn't have to simplify it all, right?
That is simplified.
Okay.
Yeah, we x squared. I mean, you can put the parentheses here if you want to, but they're not doing anything because nothing's being distributed, right? So we can just get rid of those and combine like terms. So that's a really simple one to simplify there, easier than the other one.
Okay. Let me see if it works. So it'd be 0. Okay, so then it was right.
Okay. Are there any other kinds of questions on there?
No, it's just those kind of ones. It's either g of x or f of x.
Okay. It doesn't ask about domains and ranges and all that stuff?
No.
Okay. Okay. Fair enough. Well, if you want to go work on this stuff, I'll be, I'll just be sitting here working. So you can just, I'll leave this thing going until like, I don't know, like 10:15 or something. So you can just pop back in if you want to.
Yeah, I'll go on good on this stuff. I think I understand it now.
Okay.
All right. Thank you.
Yeah, you betcha. If you have any questions though, just pop back in or send me an email or something.
All right. Sounds good.
All right. See you, Tyler.
See ya.